Hello students, I hope you have watched the previous video on the concepts of linear correlation and regression. So in this tutorial, I will guide you with how to solve problems in order to know how well you understand the concepts. So stay tuned. Here is one example problem. Let's go through the question first. The following table shows the hours studied for a test and the number of correct answers met on the test by each of the 5 employees in a company. This is the data given in the question. There are 5 sub-questions. The first question asks about regression line for predicting the number of correct answers from the number of hours studied. The second question asks about the estimation of the number of correct answers if the number of hours studied is 4. And then question number 3 is to graph the data in the table above and your answers in A, which means that the regression line. The fourth question asks about the correlation coefficient, and the final question asks about coefficient of determination R squared. And another question asks about what percentage of variations is due to the error in this survey. So basically these are the questions asked. So let's have a look at each of that later. Before we solve the question, let's analyze the data briefly. Let's say it is not mentioned in the equation what is x and what is y, then we have to determine them by yourself. So how to know which is x and which is y? One handy tip is time-based variable always represent x, which is an independent variable. The logic behind this is that time does not depend on anything else like response or things that we want to measure. So obviously in this problem, the time-based variable is the number of hours studied, which is x, and the response is the number of correct answers, which is y. If you see the employee, that's the sample size, and in this problem, the sample size is 5, because there are 5 employees. So basically, that's the brief analysis of the data before we solve the problem. So we need to know what is x and what is y in order for us to assign the term correctly in the formula of A and B. So let's have a look at the first question. The first question asks us to calculate the regression line for predicting the number of correct answers. Recall in the previous lesson, we have discussed least square method for linear regression. This is the basic form of the equation. We have to solve the A and B values in order to complete the equation. This is the formula of A and B. So the x bar represents the mean of x and y bar represents the mean of the y. So we're going to have a look at the solution for these A and B in the later slide. This is the original data given in the question. What we have to do is we have to extend this table by finding the values of x squared, y squared, and xy, as well as the summation of x, y, x squared, y squared, and xy. So you have to calculate these values by using calculator, and only then we can solve the b and a values easily. So plugging in the values of each of these terms in the b formula, you will get the final value of b of 2.075. Yeah. Please be careful when you plug in the values because there is a few terms that you have to differentiate, like the summation of x in bracket and square and summation of x squared. So those are two different terms. So the next thing is to solve for a value. This is the formula of a. We have to know what are the values of y bar, b, and x bar. So first, we have to solve for what are the values of x bar and y bar. X bar is the mean of x, which is equal to the summation of x divided by n. That gives the value of 4.2. Y bar is 11.4. So plugging in the values of x bar, y bar, and b into the formula of A, we will get the value of A equal to 2.685. So now we can solve the least square equation by plugging the a and b values into the general equation. So the equation is given as y equal to 2.685 plus 2.075x. So that answers the regression line for this problem. The second question asks us to estimate the number of correct answers if the number of hours studied is 4. So we have already the least square equation that we have developed in the previous question, where our equation is y equal to 2.685 plus 2.075. And now what we have to do basically is we have to predict what is the number of correct answers when the number of hours studied is 4. So this is a kind of prediction. Remember in the previous lesson, we have discussed about two types of prediction, interpolation and extrapolation. So interpolation is when you predict the response given any independent variable within the data. So here, the number of hours studied given is 4. So you can see the original data. It is within 1 and 7. So this prediction is interpolation. Okay. So in order to predict, we just have to plug in the values of x equal to 4 into the equation. So we will get the y value or the number of correct answers equal to 10.985. So that answers the second equation on the prediction of the response given the value of the independent variable. The third question asks us to graph the data and also the answers in A. So what are the things that we have to do is that we have to plot the given data. So this is the given data. There are 5 points that we need to plot on the graph. So what we have to do is we just have to plot all these points on the two axis graph. We know that the number of hours studied is x and number of correct answers is y. So we assign those variables accordingly. And then these are the 5 points that we plot on the graph. So this is what we call scatter diagram. It consists of many points scattered throughout the graph, remember? So that's solve the first step. The second step that we have to do is we have to plot the least square equation on the scatter diagram that we plotted before. So first thing is that we have to find what are the coordinates that we have to plot on the graph in order to represent the line. So in order to do that, we have to find whatever the values within 1 to 7 for the x values. So in this case, I choose the values of 3, 4, and 6. And then I plug it into the least square equation in order to find their corresponding y values. And then based on these coordinates plotted, I connect the line and extend the line from x equal to 1 and x equal to 7. So that's how this least square equation is plotted on a scatter diagram. So this completes this question. First, we have plotted the scatter diagram, and the second, we plotted the least square equation. The fourth question asks us to calculate the value of the sample correlation coefficient, or R. This is a formula of R. So in order to solve the R value, we have to plug in the value of each of these terms. So recall in the previous question in B, we have created this table of information, the additional columns and also the summation of each term. So plugging in the values of the terms here, so we will get the R value equal to 0.8208. So that's the R value. So what is the interpretation of this R value? So it is not equal to 1. So obviously it is not a perfect linear. But what we can say that the R value indicates that the regression line is a moderate linear correlation. So that is the interpretation of the R value. The final question is to calculate the coefficient of determination R squared and also the percentage of variation due to the error in this survey. Since we have calculated the R value in the previous question, the R value is given as 0.8208. So the coefficient of determination R squared is determined by squaring the R value. So the R square value is given as 0.6737. So what does this R square value means? If we convert the R square value into percentage, it means that 67.37% of the dependent variable is predicted by the independent variable. So the rest of it is actually due to the error. So in order to solve the second question here, what percentage of variations is due to the error? So we subtract 67.37% from 100%. That gives the value of 32.63%. So that percentage represents the variation due to the error in this survey. So that answers the question of R square and also the percentage of variation due to the error. So that's the end of today's tutorial. I hope that you have understood now how to find the regression line, make prediction or estimation, sketch a scatter diagram, and plot the least square equation on the scatter diagram, and then find the R value, R square value, and the percentage of variation due to the error. Thank you very much for watching. Stay tuned to No Statistic No Talk for more video tutorials on statistics.